Hello everyone. So this is a research-based project that I've came up with. Here, this is a mind math project. Actually, you can also call it speed math. Those of you who cannot do it in your mind, hopefully you will be able to when you practice a long time. So for those who will do it, do this thing in the pen and paper, this will be called speed mathematics. Otherwise, if you can do it in your mind, which is preferable, then it's called mind mathematics. So in competitive exams and real life, if you are an engineer, if you are slow with mathematics, then that's a very bad sign. So, and for many other reasons, people like to do mind mathematics. It's like a brain opener. You can, I mean, it will not solve huge real life problems, but it will keep your brain active to solve real life problems. I mean, it will keep you, these problems, mind math projects will keep you interested, and I mean, it will keep you engaged and your brain active so that you can achieve huge things in your life with your intellect. So this, with this end in view, I have started to make projects. I mean, I have intended to make projects on mind mathematics and speed maths and deep mathematics and game theory. And you can subscribe to my channel, and I also have a Facebook group over here. You can say IK Research Portal. If you search, you'll find my research works over there. So without any further ado, I'll just proceed with this video. So here I'm going to demonstrate how you can square a two-digit number without pen and paper, without any calculation. I mean, without any procedural regular calculation that we do, without any carry over or whatsoever like that. Only using digital root, the concept of digital root, and using this list of numbers. This list is last two digits of a perfect square. If a number ends with a perfect square, if you look at the last two digits, you'll find one of these 24. So where you can find it, I mean, you don't need to memorize it. From 0 to 24, if you square the numbers, you'll get this 25 numbers. These are the repeating numbers in this perfect square numbers. So these are the two prerequisites that we have here to proceed with this project. Suppose let's start with a simple one. 21 square. 21 times 21. Let's say 21 times 21 equals. I know the last digit should be 1, right? So it should be 3 digits. Last is 1. Second one I don't know. First one I don't know. So last is 21. Okay. So 1 times 1 is 1. Everyone knows it. So we have the last one. Always we have the last one. So first thing we'll do, we'll apply the concept of digital sum and digital root. So 2 plus 1 is 3. 3 times 3 is 9. So this number here, product, must have a digital root of 9. So if you add all these 3 digits, it will add up to 9. Now what you do, you multiply this 2. 2 times 1 is 1. Again multiply it 2. So 2 times 2 is 4. You put the 4 here. Now what's left? 4 plus 1 is 5. Only one digit left. 9 minus 5 is 4. So you have the result 441. You have 441. If you check, like 21 square is 441. I mean, this thing you can do it even in your mind. 21 square is 441. 441. Another way you can do it, you'll see which numbers end with 1. 0, 1, you have 2, 1, you have 4, 1, you have 6, 1. So 0 to 0, the middle digit is 0, either 0 or 2 or 4 or 6. 0246. Suppose if I put 0 here, I have to make it a 9, right? If you put 0 here, it must be 8, which is ridiculous. 801, it cannot never be. 20 square is 20 square is what? 400. So this 800 can never be 0. Next one is 21. So if I put 2 here, so this must be 6. So 600 something. We need 400 something. It goes to 600 something. So 21 is not a solution. If we hit 41, then we can see, oh, okay, now it satisfies. We hit 441, now it satisfies. So this is another way you can do it. This is second method. Another way you can do it. So let's try another one. 54 square feet. 54 times 54. Suppose we have this here. We know that the last one will end with 6. That's final. We need the rest of the three digits. So one thing we need to mention here is that we see that it starts with 5. So what we do is 5 times 5 is 25. So this one over here is either 2 or 3. Must be 2 or 3, highest 3, not even 4. You cannot go to 4. So from this 5 we know that either 2 or 3. The second one here is more than 25. Suppose it's 50 square, it's 2500. So second one must be greater than 5. I mean, must be greater than 4. It might be 5, 6, 7, 8, 9. Right? So I say 5 plus. 5 plus. 5 or above. Is 5 or above. So now the third digit over here, I see what it should be. What numbers end with 6? I have like 16, 36. I have like 16, 36, and 56, 76, 96. A lot of numbers. So we'll not go that way. We just do this way. 5 times 4 is how much? 5 times 4 is 20 times 2 is 40. So ends with 0. So which is the closest one? I have here and ending with 6. I have here 16, 36 and 56. 16, 36, 56. Which is closest to 0? Which which is closest to 0? The 0, 6, the 1, 6, right? So I put 1 here. That's a direct method. You just put 1 here. So we are confirmed with the last 2 digits. Now we'll look at the digital sum. 5 plus 4 is 9. 9 times 9 is 81. That's again 9. So this thing over here must be 9. So we already have 6 plus 7. Right, we already have 6 plus 1 is 7. So we need 2 more to make it a 9. So another one thing you need to remember with digital roots is that if we have 9, so suppose I say 19. What is the digital root of 19? 19 is 9 plus 1 is 10. 10 plus 0 is 1. So 9 doesn't count here. So in this slot I have here 5 plus. I can put it 9 here. This will not change the digital root. We already have 2 here. 2 or 3. We already have the option here. So we get rid of 3. So thus we get to the answer 2916. I hope these things are clear. I will make another video in the future if this one is not clear. So let's make an overview. First of all, you will take the first digit squared. 20 squared is 400, you know. So the first digit is either 4 or 5, so you take that note. Last one, we always have the 1. I mean, you already know it, 1 times 1. So only left is the middle one. It can be easily calculated using the digital root. So and if you are stuck, you can do trial and error with all the numbers ending with the last digit here. So what we did here, first of all, we knew right away, we knew the last digit is 6 from the 4 here, and first digit is 2 or 3 from the 5 here, because 5 times 5 is 25. Also have the first 2 digits here. The second one is minimum 5. Might be 5 or 6 or 7 or 8 or 9. 5, 6, 7, 8, 9. So we have 5 options here. We have 2 options here. And this one over here, how did we calculate? We multiply the digits over here. This thing also applies. If you want to do it quickly, 2 times 1 is 2, times double it is 4. This thing is minimum. This thing is 4. So you put 4 here, you put 4 or 5 here, do trial and error, apply the digital root property, you match. If it matches with the answer, you got it. I mean, over time it will become so clear with you. So 5 times 4 is 20, 20 times 2 is 40, so 40 ends with 0. So this thing must be greater than 0. I mean, must be greater or equal to 0. I mean, must be very close to 0. I mean, this digit should be very close to 0, or equal. Must be equal or very close. So we have 1 6 here, we have 3 6, 5 6, we have 9 6, 7 6, 1 3 5 7 9, 1 3 5, all the even ones, right? So 1 3 5, which is closest to 0? We got 40, right? So which is closest to 0? 1 6, right? So 1 6 is final. So that's how we calculate it. And application, I mean, if you do it with 3 digits, you can figure it out, but you might need help. So just keep this project up to 2 digits and keep on practicing. Right, so I hope this one helps, and maybe if you like it, I'll make more videos like this. So thanks for watching.